Okay, so good day to everyone. By the way, I'm Engineer John Renal Capellanes and welcome to Jacob Engineering Video Tutorials. Okay, so ang subject natin ngayon class is statics of rigid bodies. Okay, so nandito na tayo sa Module 3. Okay, so ito yung ating part 1. Okay, so in Module 3, we will discuss parallel coplanar force system. Okay, so in this video, we will discuss its definition and concept. And may dalawang sample problems tayo dito, class, na isosolve. Okay? So, let's start na, class, no? Okay, so parallel coplanar force system. The parallel coplanar force system refers to the number of forces which are parallel to each other with their lines of action. This force system is mostly used in the analysis of simple beams with number of point loads. Okay, so para ma-visualize natin siya, class, is mas mabuti i-figure out natin siya. Okay, so we assume a length of a beam. Okay, ito yung ating beam, ito yung ating x-axis, ito yung ating y-axis, at ito yung ating point O. Okay? So, in this beam, we will apply a force system. Okay, so ito yung ating F1, okay, which applied a distance x1 from point O. Okay, and ito naman yung F2, which applied x2, a distance x2 from point O. Okay, and ito yung ating F3, okay, and ito yung ating F4. Okay, so, in this force system, class, okay, may dalawang forces tayo. Okay, F1, F2, F3, and F4. Okay, their line of action, class, okay, their line of action is vertical. Okay, all of the forces. Okay, yung line of action niya is vertical. Okay, so, anong nanonotice natin dito? Okay, manonotice natin dito, class, na yung all forces natin is parallel to each other. Okay, since yung force system natin is a coplanar force system, so that's why, class, tinawag siyang parallel. Okay, kasi parallel yung forces niya. Okay, so tinawag itong parallel coplanar force system. Okay, so by the way, class, yung parallel coplanar force system, hindi lang vertical forces na. Okay, it can be also in horizontal forces. Okay, basta parallel yung force system, class. Okay, parallel yung mga forces niya. Okay, so that is a parallel coplanar force system. Okay, so if we want, class, if we want to solve the resultant force of these four forces, we can simply direct that the resultant force is directed either going upward or going downward, no? Pero sure tayo, class, na yung resultant force natin is vertical. Okay, since yung F1 natin, yung at F2 and F3 and F4 is a vertical force, no? Hindi pwedeng mag-i-incline niya, class. Okay, kasi walang horizontal component naman yan. Okay, so ito yung ating resultant force R. Okay? And then, if we want to locate, class, okay, if we want to locate the location of the resultant force, okay, from point O, okay, ito yung ating location, class. Okay, so tinawag siyang bar X, class. Okay, so bar X, the distance from point O to the resultant force. Okay, so, okay, transfer lang, class. Okay, so ito yung ating bar X. Okay, so if we want to solve the resultant force, class, that is simply resultant force, okay, is equal to the summation of forces vertical. Okay? Okay, since yung resultant natin, since yung resultant force natin, class, is going downward, so if we summation of forces vertical, class, or y, we can say, class, or mas mabuti mag-assume tayo na going downward is positive. Okay? So, ito yung formula niya, class. Okay, general na formula ito. So, resultant force is summation of forces is equal to, okay, so nag-assume tayo class na yung downward force is positive. So that's why plus F1 yan. Okay? And then F2 is going downward. So plus F2. Okay? And also F3. F3 is going downward. So positive yan. So plus F3. Okay? Since yung F4 natin is going upward, and we assume that going downward is positive and going upward is negative. So therefore, F4 natin is a negative force. Okay, so that's why minus F4 yan class. Okay, so to make this a general formula, so i-continue ko lang to. Okay, continue ko lang. Okay, so plus dot plus Fn. Okay, so ito yung ating general formula in solving the resultant force. Okay, yun lang ang tandaan class. The resultant force is only the summation of forces. Okay, so if we want class to solve the location of bar x, how can we solve class? How can we find bar x? Okay, so in Varignon's theorem class state that the moment at a point, okay, i-draw ko lang kasi the moment at a point, okay, tawagin lang ko to na point O. Okay, so the moment of a point O is equal to the summation of moment produced by every forces that act on a body. Okay, yun yung definition ng Varignon's theorem. Okay, so in using that theorem class, we can say that the moment at point O, or the moment produced by every forces F1, F2, and F3, and F4 is equal to the moment produced by the resultant force R. Okay, so equal lang sila class. Okay, so tawagin ko lang yung MO is the summation of moment produced in every forces. Okay, F1 and F2 and F3 and F4. Okay, and then ang gawin ko class is kung i-isolate ko to, okay, yung R na ito, okay, yung R natin, yung moment mapuproduce niya is a clockwise moment. Okay, tawagin natin siya as MR. Okay, is the moment produced by the resultant force, MR. Okay, so using the Varignon's theorem class, we can say that MR, okay, is equal to the summation of moment by summation of moment at point O. Okay, we can simply say that the summation of moment O is equal to the summation of moment produced by every forces. Okay, so therefore class, ang formula niya ito yung formula niya. Okay, yung moment resultant natin, or the resultant moment, is equal to R times X. Okay, so resultant, ito yung ating resultant, the force, and its moment arm. Moment arm niya class is ito yun, bar X. Okay, so that's why R times bar X, that is MR. Okay, is equal, then summation of moment at point O. So that's why F1 natin, F1 is F1 times X1, at yung moment produced ng F2, that is plus F2 times X2. Okay, at yung F3 natin is plus F3 times X3. Okay, so minus, since F4 natin is going upward, okay, so it produce a clockwise moment, a counterclockwise moment. Okay, and then class, yung MR natin is going clockwise. Okay, so mag-assume na lang tayo class, para hindi ma-negative yan. Okay, mag-assume tayo na clockwise is positive. Okay, para hindi ma-negative yan. Okay, so that's why minus to. Okay, minus to class. Okay, so minus F4 times X4. Okay, kasi yung F4 natin will produce a counterclockwise moment. Okay, so that's why minus yan. Okay? Okay, so resultant of a distributed load. Okay, so the resultant of a distributed load is equal to the area of a load diagram. Okay, so it is acting at the centroid. Okay, it is acting at the centroid of the area as indicated. Okay, so the figure below shows the three common distributed loads, namely rectangular load, triangular load, and trapezoidal load. Okay, so ito yung ating three sample of rectangular load class. Okay, so ito yung ating rectangular load, okay, which distributed load ito class. Okay, meron siyang intensity class, no? Ito yung ating intensity, which is the load per unit of length. Okay? When itong distributed na load na ito class, okay, kapag kunin natin yung resultant force niya, okay, resultant force niya class is equal to the area of the rectangle. Okay? So ito yung resultant force niya class. R, which is equivalent to, okay, the intensity of the distributed load, or WO class, times the length. Okay, kasi ang unit nito class is load. Okay, load per okay, erase ko lang class, no? Okay, is a load nito, it can be either sample lang class is kilonewton per meter. Okay, times the length. Okay, so resultant force niya class is a concentrated load. Okay, so resultant is equal to the area of the rectangular loading class. Okay, and then yung location ng R class is state that the center of the area. Okay, so since yung rectangular naman class, we can simply say that the resultant force will intersect L over 2 of the length class. Okay, ito yung location niya. Okay, nasa sa center class. Okay, nandun siya sa center yung resultant force niya. Okay, how about yung triangular load? Okay, so ito yung ating triangular load class. Okay, which is ito yung length L at ito yung ating intensity of loading. Okay? So yung unit class, it can be kilonewton per meter, meter per newton per meter, or it can be pound per feet. Okay? Basta distributed loading sa class. Okay? Distributed loading. So, since a triangle naman ito class, okay? So, kapag kunin natin yung resultant force, okay? Resultant force class. Resultant force is equal to the area of this triangular loading class. Okay, which is simply equal to R is equal to 1/2 times base times height. That is the formula of a triangle, the area of a triangle. So times WO times length. Okay, kasi ito yung height na class. Okay, ito yung height niya. Okay, ito yung height niya class. WO. Okay, nag-gets nyo ka? Okay, so kapag kunin natin yung location niya class, okay, resultant force. Di ba sinabi niya na yung resultant force mo mag-act or mag-intersect at the centroid of the area. Okay, so ang centroid of the area class, okay, dito yung center niya. Okay, that is 2/3 of the length L. Okay, that is 2/3 of the length L class. Okay, kapag nagsimula tayo dito, that is 2/3 times L. Okay, kapag nagsimula naman tayo dito class, yung location niya from this point to the resultant force, that is 1/3 times L. Okay? And then, yung third class is may tinatawag tayong trapezoidal. Ito yung ating trapezoidal distributed loading. Okay, so yung length niya L at ito yung ating intensity. Okay, so ang height niya ito class is WO1 at ito naman natin WO2. Okay, where WO1 is not equal to WO2. Okay, kasi mas mataas yung intensity dito class. Okay, kasi increasing class, increasing yung intensity niya. Okay, so kapag paano natin kunin yung resultant force ng trapezoidal class. Okay? kapag kunin natin yung only the resultant force class, okay, that is simply what is the area of the trapezoid class? That is h1 plus h2 divided by 2 times base. Okay, that is the formula of area of a trapezoid. Okay, so kapag kunin natin yung resultant, easy lang yung class. Okay, kasi madadirect natin solve in area niya. Okay, pero kapag kunin natin yung location ng resultant force ng trapezoidal distributed loading na ito class, mahihirapan tayo dito. Okay, so mas mabuti class na we will divide a trapezoidal load into 2 parts. Okay, ito yung gawin natin class. Okay, ito yung ating trapezoidal loading. Okay, so ang gawin natin, i-separate natin class. Okay, i-divide natin siya into 2 parts. Okay, ito yung ating area 1 at ito yung ating area 2. So, ito yung ating area 1 class at ito naman ato, ito yung intensity, ang height nito class is WO1. Okay, WO1 yan. Okay, and how about yung height na ito? How to determine class? Yung height na, itong height na yan. How to determine ng height na yan, class? Okay, that is simply WO2 minus WO1. Okay, so that's why, ito yung class, oh. Okay, WO2 minus WO1. Okay, so WO2 minus WO1 plus WO1, that is equivalent to WO2. Okay, gets niya ako? Okay, so, ito yung ating F1 class, or the resultant force of a rectangular distributed loading. Okay? Ito yung F1 natin. Okay? And then, ito yung ating F2 class, or the resultant force of a triangular loading. Okay? So, F2 yung class. Okay? Ang F1 natin, kapag located siya, 1/2 times L. Okay? And then, yung location niya ng F2 class, okay, from this point, is equal to 2/3 times L. Ito yun. Okay, ito yun. Okay, that is 2/3. Okay, that is 2/3 times L. And ito is 1/2 times L. Yun lang ito class. Okay, L over 2. That is L over 2. Okay? So, mag-sample problem na tayo dito. Okay? Okay, so sample problem 3.1. Okay, so for the beam loaded as shown in figure SP 2.5, determine the resultant of loads in kilonewton. Okay, so B is determine the location of the resultant load from the left support in meters. Okay, so ang pinadidetermine dito class is yung resultant force ng all forces na ito. Okay, at yung location niya, okay, location ng resultant force from point A. Okay, kapag class no, ito yung kailangan tandaan natin. Kapag kunin natin yung resultant force ng force system, is focus lang tayo sa loading. Okay, focus lang tayo ng loadings niya, class. Okay, kasi wala pa tayo sa equilibrium. Okay? Okay, so ito yung solution natin. Okay, so we assume that ito yung ating resultant force, class. Assumption lang natin to, na yung resultant force natin is going downward. Okay, assumption lang natin ito, class. Okay, pero by the way, ma-check natin ito, class, kung yung resultant force natin is going downward ba or going upward. Okay? Okay, so resultant force is simply the summation of Fy, and then we assume that going downward is positive. Okay? Assume tayo, class, na yung downward natin is positive side. Okay, so therefore, resultant force, okay, so resultant force, ito yun, class, resultant force, okay, resultant force is equal to, okay, is equal to, explain ko lang muna, class, explain ko ito one by one. Okay, resultant, summation of Fy. What is the summation of Fy, class? Unahin ko to si 20 kilonewton. Okay, 20 kilonewton, class, is going downward. Okay, so that's why positive yan. Okay, kasi nag-assume tayo na going downward is positive. Okay, so that's why plus 20 yan, class. Okay, and then yung 10 kilonewton, class. Okay, yung 10 kilonewton natin is going upward. Okay, kapag upward tayo class, nag-assume tayo is positive yung downward natin and yung upward natin is negative. So since yung 10 kilonewton natin is going upward, so that's why class, minus 10 kilonewton yan. Okay, and then plus 30 kilonewton. Okay, 30 kilonewton is going downward, so plus yan. Okay, and then 15 kilonewton is going downward, so plus 15, and last is 5 kilonewton, that is going upward, so minus 5 kilonewton. Okay, so by solving the resultant force R, we compute that 50 kilonewton, that is equivalent to 50 kilonewton, and that is positive. Okay, that is positive, and we assume that positive is going downward. Okay, so therefore we can conclude that the resultant force that act on a beam is going downward. So meaning yung assumption natin class that the resultant force is going downward is correct. Okay, gets nyo ka? Okay, kapag negative yan, okay, so therefore the resultant force is going in upward direction. Okay, gets nyo ka? Okay, so next is, ito na yung answer na A natin. Okay, so B, determine the location of the resultant load from the left support in meters. Okay, so ang gawin natin class, ito yung ating location. Okay, ito yung ating location ng resultant force from point A. Okay, kasi from left support tayo. Okay, so that's why dito tayo magre-reference line. Okay? Okay, so ang gawin natin class, okay, kailangan tandaan nyo lang na yung moment produced ng resultant force is equal to the summation of moment of all of the forces. Okay, ulitin ko lang class. Kailangan tandaan nyo ito. The moment produced by all of the forces, okay, is equal to the moment produced by the resultant force. Okay, equal lang sila class. That is the theorem of Varignon's theorem. Okay, so that's why class we can say that that Rx times that R times bar x, this is the moment of that is the moment produced by the resultant force R times its moment arm bar x. Okay, so ito yung class, R times bar x is equal to the summation of moment. Okay, moment is equal to force times distance or force times x, which x is represent the distance with respect to horizontal. Okay? And class, no? Sure na tayo class na tama tayo class na yung resultant force R is going downward. So if we apply moment at A class, okay, it can produce a clockwise moment. Okay, it can produce a clockwise moment. Okay, so to make our solution simple class, okay, we will assume that clockwise moment is positive. Okay, yun na class, no? So therefore, R natin, what is our R class? R. Okay, so R natin is 50 kilonewtons times bar x. Okay, so ito yun class. Okay, explain ko lang one by one ito class, no? So okay, so ito yung class R, yung R natin is 50 kilonewton times, okay, times bar x. Okay? Is equal. Okay, so is equal to summation of forces Fx. Okay, so unahin ko to si 20 kilonewton class. Okay, unahin ko si 20 kilonewton. Okay, so 20 kilonewton will produce a clockwise moment. Okay, clockwise moment at point A. So therefore, the moment produced by 20 kilonewton is a positive moment. Okay, kasi nag-assume tayo na clockwise is positive. Okay, so that's why 20 times 1.5 meter yan class. Okay, 20 kilonewton times 1.5 meter. Okay, so ito yung force niya at ito yung man yung moment arm. Okay, ang next class is yung 10 kilonewton. Okay, yung force natin. Okay, yung 10 kilonewton force natin class, that is going upward. Okay, so if we moment at A, it will produce class a counter, okay, a counter moment at point A. Okay, so that's why minus yan. Okay, so minus force times distance. Okay, so the force niya class is 10 kilonewtons times the moment arm. What is the moment arm class? Okay, of 10 kilonewton, that is 1.5 plus 1.5, that is 3 meters. So 10 times 3. Okay, gets nyo ako class? Okay, how about yung 30 kilonewton natin? Okay, so ito yung 30 kilonewton natin class. And 30 kilonewton will produce, okay, will produce a clockwise moment at A. Okay? Yung 30 kilonewton natin class will produce a clockwise moment at A. So therefore, positive yan. Okay? Kasi nag-assume tayo na clockwise is positive. So that's why plus, okay, force times distance. What is the force class? 30. Okay, so 30, what is the moment arm? Okay, so the moment arm from point A to the perpendicular force class is equal to 1.5 plus 1.5 plus 1.5. That is equivalent to 4.5 meters. So times 4.5 meter. Okay? And then yung 15 kilonewton class will produce, okay, will produce a clockwise moment. Okay? So therefore positive yan. Okay? So positive. Okay? And then times force times distance. What is the force? That is 15. 15. Okay? What is the moment arm? Okay? So ito yung moment arm niya class. Okay? Ito yung moment arm niya. Okay, what is this? What is that distance class? So 1.5 plus 1.5 plus 1.5 plus 1.5, that is equivalent to 6 meter. Okay, so that's why 15 plus 15 times 6 meter yan class. Okay, gets nyo ako? And then the last force class, ito yon, and ito yung force class is going upward. So if we apply a moment at A, it will produce a counterclockwise. And we assume that clockwise is positive and counter is negative. Since counter naman yung mapuproduce ng 5 kilonewton class, so that is negative. So that's why minus yan. Okay, so times force times distance. So ang force na class is 5 kilonewton times what is the perpendicular distance or the moment arm of the 5 kilonewton class. Okay, ito yung distance na ito. Okay, ito yung distance na yung class. So 1.5 plus 1.5 plus 1.5 plus 1.5 plus 1.5, that is equivalent to 7.5 meter. Okay? So that's why 7.5 din class. Okay, so to solve the bar x, okay, so to solve bar x, okay, so to solve bar x class, we compute that bar x is equal to 3.75 meter. Okay, from point A. Okay? So, yun lang class, no? Yun lang. Okay? So, that is our final answer. Okay? So, sample problems tayo in number 2. Okay? Okay, so sample problem 3.2. Okay, so the figure below shows the load diagram acting on the retaining wall. Determine the following. The magnitude of the resultant force in kilonewton. Okay? The location of the resultant force from the bottom of the wall. Okay? Saan yung bottom of the wall natin, class? Okay? Yung bottom of the wall natin, class, is nandito. Nandito yung bottom of the wall natin. Okay? Since, class, yung distribution ng loadings natin, class, is in horizontal to the left, we can directly say that the resultant force will directly yung direction ng resultant force natin is it will go to the left. Okay, horizontal to the left. Okay? Na-gets nyo ako, class? Okay, so ang gawin natin nito, class, is isi-separate natin siya. Okay? Isi-separate natin siya, which magka-create tayo, class, na rectangle at yung triangle. Okay? i-separate natin class. Kasi kasi sa problem class is pinadidetermine yung location of the resultant force. Okay? Kapag trapezoidal yung distribution ng load class, we can easily compute the resultant force, but we cannot directly solve its location. Okay, the location, the resultant force. Okay, that's why class, since pinadidetermine tayo ng location of the resultant force, so dapat class, i-divide natin siya into parts. Okay, it can be a rectangular or a triangular. Okay, but avoid class a trapezoidal. Okay, so anong dapat natin gawin dito class? Okay, so ito yung intensity niya class, no? Okay, intensity dito class, okay, at the top is 10 kilonewton per meter. Okay, and then at a depth of 1 meter class, yung intensity niya is 20 kilonewton per meter. Okay, and then after a depth of 1.2 meter class, yung intensity niya dito class is 50 kilonewton per meter. Okay, and then after 1.5 meter depth, yung intensity niya dito class is 60 kilonewton. Okay, ulitin ko lang class, yung 60 kilonewton class is ito yung width na yan. Okay, yung 50 ito yung width na yan, at ito yung width ng 20 at ito yung width ng 10 kilonewton. Okay? So ang gawin natin class is isa-separate lang natin siya. Okay, so ito yung solution natin. Okay, so paano na by the way, maraming solution ito. Okay, so nagdepend lang sa solution niyo ito class. Okay, so ito yung gawin ko class, no? Okay, so I will create a line. Okay, mag-create ako ng line na yan. Okay, and itong line na yan. Okay, and then itong area na yan class, ito, tawagin ko siyang area 2. Area 1. Okay, tawagin ko siya ng area 1 class. At itong area naman nito class, okay, tawagin ko to ng area 2. Okay, and then itong triangular ng area na yan class, okay, tawagin ko siya ng area 3. Okay, and then itong triangular area na yan class, tawagin ko siyang area 4. Okay, and may natitira pang class na trapezoidal, okay, trapezoidal distribution load. Okay, so anong dapat natin gawin dito class? Okay, so mag-create lang ako ng vertical line class. Okay, dito, magsisimula ako dito. Okay, which, yung area na dito, class, this is a rectangular and not a triangular dito. Okay, so that's why, ito yung, tawagin ko siya ng area 5 at ito yung ating area 6. Okay, so, ilang area na involved, class? Okay, ilang area ng distribution load ang na-create natin? Okay, how many? There are 6. So, therefore, we can solve 6 resultant force with respect to the area class. Okay? So, makasolve tayo ng resultant force ng area 1, area 2, area 3, area 4, area 5, and area 6. Okay? So, may 6 tayo class. Okay? May 6 tayo na forces na yan. Okay? And then, ito yung ating by the way, class, no, solvein muna natin yung intensity niya. Okay, so ito yung ating area 1, class. Okay, kasi na-separate na natin yan. Itong width na yan, class, that is 20 kilonewton. Okay, kasi, class, 20 kasi ito. Okay, 20 kasi yan, class. Okay, so therefore, by creating a vertical line, this is also 20 kilonewton, class. 20 kilonewton meter. Okay, how about yung dito class? Okay, how about dito? Magkano naman dito class? Okay, so this is 50 kilonewton class, no? And from this point to that point, that is 50. Okay, so 50 kilonewton minus 20, and that is 30 kilonewton per meter. Okay, so since 60 kilonewton naman nito class, yung width na yan class, no, that is the total of 60 kilonewton per meter. So ang natitira na lang class is 10 kilonewton per meter. Okay? And then class, yung width na yung top class is 10 kilonewton meter. Okay, so ilang width ni ito class? Itong base ng area 6. That is 20 minus 10. Okay, so that's why 10 kilonewton per meter ito, class. Okay, nag-gets nyo ako? So, ang gawin natin, class, is solvein muna natin yung resultant force with respect to its area. Okay, so ito yung ating F1, class. Tawagin natin yung resultant force ng area 1 is F1. At ito naman is F2. Okay, ito naman yung ating F3. At ito naman yung ating F4. Okay, and ito naman yung ating F5, and ito naman natin yung F6. Okay, we can locate the location of the resultant force or F1, class. Okay, F1, F2, and F3, F4, F5, and F6. Okay, we can direct solve it, class. Okay, kasi alam na natin yung location ng centroid ng area niya. Okay? So, example lang, class, yung area 1 natin, yung location ng F1 niya is at the center. Okay, so what is this length, class? That is 1.2 plus 1 plus 0.5. Okay, that is equivalent to 2.7 meter. So, therefore, the location, yung centroid na ito, class, from the bottom, that is 2.7 times 0.5. Okay? So, unang gawin natin dito, class, is solvein muna natin yung its force and its location. Okay? Location of the force. Okay? From the bottom. Okay? So, mag-reference tayo, class, from the bottom. Okay? Mag-reference tayo dito, class, ha? Okay, dito nga point, class. Okay, dito tayo mag-reference. Tawagin natin siya, class, as point O. Okay? So, F1, class, no? Ito yung ating F1. F1 natin is the area of this rectangular loading, class. Okay? That is the base times height. Okay, so that is 20 kilonewton at 20 kilonewton per meter times this height, class. Okay, yung height na yan, class, is equivalent to, okay, yung height na ito, class, that is equivalent to 1.2 plus 1 plus 2 plus 0.5, that is equivalent to 2.7 meter, class. Okay, so that's why yung F1 natin is equal to 20 kilonewton per meter times 2.7 meter, and that is equivalent to 54 kilonewton. Okay, that is our F1, class. Okay, and how about its location from the bottom? Okay, kasi yung pinadedetermine, class, is the location of the resultant force from the bottom of the wall. So, mag-reference tayo from the bottom of the wall. Okay, para direct yung answer natin, class. Okay, so therefore, yung y sub 1 natin, class, is equal to, that is 2.7, yung height na ito, class, 2.7. At rectangular naman yan is nasa center yan, class. So, is equal to 2.7 times 0.5. Okay, and that is equivalent to 1.35 meter. Okay, so that is the force F1 at yung location ng F1 niya is 1.35 meter from the bottom. Okay, so how about yung area 2, class? Okay, so yung area 2, ito yung ating area 2, class. Okay, tingnan niyo yung area 2 natin. Okay, to solve area 2, okay, to solve F2, that is the area of this rectangular loading, class. Okay, and then the area of that rectangular loading, class, that is equivalent to F2 is equal to 30 times this height, class. Okay, so what is this height? Okay, so 1 meter plus 0.5, that is equivalent to 1.5 meter. Okay, so that's why 30 kilonewton per meter times 1.5 meter, and that is equivalent to 45 kilonewton force. Okay, and what is the location of F2 from the bottom? Okay, from the bottom, class, what is the location? Okay, itong location na ito, class. Okay, yung location na yan. Okay, since 1.5 naman yan, class. Okay, since 1.5 naman yan. So, therefore, rectangular naman yan. So, therefore, ito ay 0.75 meter. Okay, so that's why yung y2 natin class is equal to 1.5 meter times 0.5 and that is equivalent to 0.75 meter. Okay? And how about yung area 3 natin class? Okay, yung area 3 natin class is a triangular loading. Okay, and then F3 natin or the resultant force of this triangular loading is equivalent to F3. Okay, what is the formula of area of a triangle? That is 1/2 times base times height. Okay, so ito yung base natin at ito yung height natin. Okay, so yung base niya is 10 and yung height niya is 1.5. Okay, so therefore, yung F3 natin is equal to 1/2 times 10 times 1.5. And that is equivalent to 7.5 kilonewton. Okay, so how about yung location niya, class? Okay, location from the bottom. Okay, so from the bottom, ito yung class, oh. Okay, so since yung height niyan, class, is 1.5 meter. Okay, so therefore, that is 1/3. Okay, that is 1/3 class sa 1.5 meter lang. Okay? Nagets nyo ka? So, that's why, class, yung y sub 3 natin is 1/3 times 1.5. Okay? So, kasi nandito yung, dito tayo nag-reference, class. Okay? Kapag dito, that is 2/3 times 1.5. Pero kung dito tayo mag-reference, class, that is 1/3 of the height. Okay? So, that is equivalent to 0.5 meter. Okay? Okay, so, F4 na tayo, class. Area 4 tayo, class. Okay, how to solve F4? That is, this is a triangular loading, so area times base, 1/2 base times height. That is, F4 is equal to 1/2. What is the base? Okay, so yung base na ito, class, that is equivalent to 30. Okay, 30 ito. Okay, so 1/2 times 30 times height. What is the height, class, of area 4? That is equivalent to 1.2 meter. Okay, so 1/2 times 30 times 1.2, and that is equivalent to 18 kilonewton. Okay? And then how about what is the location? Okay, what is the location of F4 from the bottom of the wall? Okay, ito yung class, oh. Ito yun. Okay? Ito, class, this is, since 1.2 yung height na, class, that is 1/3 of the height. Okay, 1/3 of the height, class. Okay, plus 1.5 meter yan, class, oh. Okay, 1.5 meter yan. Okay, so therefore, the height of the height of F4 from the bottom, class, is equal to, y sub 4 is equal to 1/3, okay, times 1.2 meter plus 1.5. And that is equivalent to 1.9 meter. Okay, na-get nyo, class, 1.5 plus 1/3 ng 1.2. Itong location na yan. Okay? Tapos na tayo sa area 4, class. And then mag-area 5 tayo. Okay, how to solve F5. F5 is the area of the rectangular loading. Okay, so therefore, okay, this is 10 and the height, class, is 1 meter. Okay, so therefore F5 is equal to 10 times 1. Okay, so that is equivalent to 10 kilonewton. Okay, how about its location from the bottom, class? Okay, what its location from the bottom? Okay, its location from the bottom, that is 0.5 plus 1 plus 1.2. Okay, that is equivalent to 2.7. 2.7 ito, class. Ito, that is 2.7. Okay, that is 2.7 meter. Okay, since rectangular naman yan, so half ng 1 meter. Okay, so plus, okay, 0.5 meter, yan. Okay, so 2.7 plus 0.5, that is equivalent to 3.2 meters. So therefore, y sub 5 is equal to 0.5, okay, plus 1.2 plus 1.5, okay? So that is equivalent to 3.2 meter. Okay? And the last area, class, is area 6. Okay, so yung F6 natin is the area of the triangular loading of area 6. Okay, so F6 is equal to 1/2 times 10 times the height times 1. Okay? So that is equivalent to 5 kilonewton. And what is location, class? What is the location of F6 from the bottom? Okay? Anong location niya, class? Okay, this is 2.7. From this point to that point, that is 2.7 meter. Okay, that is 2.7 meter. Okay, and yung height ng triangle class, that is 1 meter. And ito yung height na yan, that is 1/3 of 1 meter. Okay, so 1/3 times height times 1 meter plus 2.7. And that is equivalent to, okay, so y6 natin is 1/3 times 1 plus 1.2 plus 1.5. And that is equivalent to 3.03 meter. Okay, so una tayo sa question 8 class is to determine the magnitude of the resultant force in kilonewton. Okay, so therefore class, okay, so resultant force is equal to summation of forces at x. Okay, assume that that going to the right is positive. Okay, assume na lang tayo class kasi kasi yung resultant force natin class is going to the left. Okay, we can simply say that yung resultant force natin is talagang going to the left yan. Hindi mag-going to the right yan. Okay, kasi yung distribution ng loading natin class is to the left. Okay? So, yun class, no? So, mas okay class na yung assumption natin is going to the left is positive. Okay, para yung R natin hindi mag-negative sign. Okay? So resultant force is equal to the summation of Fx. Okay? So therefore resultant is equal to F1 plus F2 plus F3 plus F4 plus F5 plus F6. Since yung direction ng F1 natin class up to F6 is same direction. Okay, same direction class. And then, kapag same direction, same sign. Okay, so ito yung ating F1, ito yung ating F2, ito yung ating F3, and ito naman na yung F4, ito yung ating F5, and ito yung ating F6. Okay, so i-add lang natin siya class, and that is equivalent to 54 plus 45 plus 7.5 plus 18 kilonewton plus 10 plus 5 kilonewton, and that is equivalent to 139.5 kilonewton meter. 139.5 kilonewton. And that is our final answer in A class. Okay? Nag-gets nyo ako class? And B, how about in solving B class? Okay, location of the resultant force from the bottom of the wall. Okay, so gamit lang tayo ng Varignon's theorem class. Na yung moment ng resultant yung moment na produce ng resultant force class is equal to the moment produced in every forces that act on the retaining wall. Okay, gets nyo ako? So ito yung resultant force nito class. By the way, transfer ko lang class ha. Okay, transfer ko lang, no? Wala nang space. Okay, so ito yan, walang nagbago dyan class. Okay, in-arrange ko lang. Okay, nag-arrange lang ako class. Okay, so yung resultant force natin class is assume tayo nandito. Okay, nag-assume lang tayo class ha. Nag-assume lang tayo ng resultant force ng all resultant force ng entire distribution load class. Ito yung ating R class. Okay? Ito yung ating R. And then the resultant, we know that class, that the resultant force R is equal to the whole area of the distribution. Okay? Ito, kapag nakuha mong area na yan class, total area, that is equivalent to the R. Okay? Kuha niyo ako? And then, kapag, ang gusto natin kunin class is the location. Okay? Is the location of the resultant force from the bottom of the wall. Okay, so from the bottom of the wall. And then, tawagin natin siya class itong bar Y. Okay, bar Y tayo class kasi vertical tayo. Okay, kapag horizontal tayo class, bar X. Okay, na-gets nyo ka? Okay, so apply tayo class in Varignon's theorem. That is the moment produced by the resultant moment is equal to the summation of moment produced in every forces. Okay, so that's why Ry R times bar Y is equal to the summation of force times Y. Okay, gets niyo ako? Okay, so ilang forces ilang force na iti-take up natin dito, class? That is 6. Okay, so therefore 6 moment ito, class. Okay, yung summation of Fy natin is 6 moment. Okay, kasi 6 forces, class. At yung 6 forces natin can produce moment at the bottom of the wall. Okay, so in this equation, class, okay, by the way, okay, yung alam natin yung resultant force natin, class. Okay, alam natin yung resultant force natin is going to that direction. Okay, and then we know that the moment at this point, class, it will produce a counterclockwise moment. Ito yung moment niya, class. Okay, and then sure na tayo, class, yung moment at this point is a counterclockwise moment. Okay, so kapag nag-summation tayo, class, kapag nag-summation tayo ng summation of Fy tayo, class, we assume that going clockwise is positive. Okay, nag-gets nyo ako? Okay, nag-gets nyo ako, class? Okay, so okay, so continue tayo, class, no? Okay, so resultant force natin, that is 139.5. Okay, so that's equivalent to 139.5 times bar Y. Okay, that is the resultant moment. Okay, and then ito yung resultant moment at yung summation of Fy natin, class. Okay, so unahin natin si, okay, by the way, may isa pa pala. Okay, unahin natin si F1, class. Okay, so F1 is equal to the moment at this point, kasi at this point is equal to F1 times Y sub 1. Okay, so moment F1 is produce a counterclockwise moment. And we assume kanina na counterclockwise natin is a positive. Okay, so that's why positive yan. Okay, since same direction naman yan, yung lahat ng forces naman, all forces F natin, class. So therefore, all of the moment is a positive sign. Okay, so that's why 54 times the moment arm. What is the moment arm of 54 kilonewton? That is 1.35 meter. Okay, yung F2 natin, class. Okay, F2 natin is 45 kilonewton times what is the moment arm? Okay, moment arm is from the perpendicular distance of the force from this point. Okay, and that is equivalent to, okay, that is equivalent to 0.75 meter. Okay, so 45 times 0.75. Okay, how about F3? F3 natin is 7.5 kilonewton times the moment arm niya, class. Okay, the moment arm niya is 0.5. Okay, so times 0.5. Okay, how about yung F4 natin? F4 natin is positive na yan, class. Yung F4 natin is 18 kilonewton. And what is its moment arm, class? Yung moment arm niya dito, that is equivalent to 1.9 meter. Okay, so 18 times 1.9 meter. Okay, and then how about yung F5 natin? Ito yung F5 natin, class. And yung F5 natin is 10 kilonewton. So 10 kilonewton, what is the moment arm of F5 from the bottom of the wall? Okay, and that is equivalent to 3.2 meter. Nasolve na natin yan kanina, class. Okay, so 10 times 3.2 meter. Okay, and the last is F6. What is our force F6? That is 5 kilonewton. So plus 5 kilonewton, what is the perpendicular distance or the moment arm from this point to the force F6? That is 3.03 meter. Okay, so that's why plus 5 times 3.03 meter. Okay, so solve natin si bar Y, class. That is equivalent to, okay, mag-calculate lang ako, class, no, to check. Okay, check natin, class, is 139.5 times x is equal to 54 times 1.35 plus 45 times 0.75 plus 7.5 times 0.5 plus 18 times 1.9 plus 10 times 3.2 plus 5 times 3.03. Okay, shift, calculate. Okay, solve for x is mag-input lang ako ng probable value or yung estimate ng ito class. So, input lang ako ng 2 and then equal lang ako class. Okay, by the way, may check ko muna class ha, 54. Okay, 139.5. 54 times 1.55 times 0.75. Okay, 18. Okay, ito class, nalimutan, no? Okay, may error tayo. Na plus ito class. This is times. Okay, so shift calculate. And then, yung answer natin class is 1.375 meter. Okay, so that's why yung answer natin class is, yung bar y natin is 1.375 meter. And that is our final answer. Okay? So, that's it, class, no? Okay, so the end of part 1. Thank you for watching and good luck and God bless. Thank you all.